Now let's try to look at some past questions that are related to integration. So in the first question, we are told to integrate x squared minus square root of x over x with respect to x. So to go about this, like I've explained before, when you have something of the form a plus b over c is the same as having a over c plus b over c. So we can easily split this out to have what? X squared over x minus the square root of x over x. So this is pretty straightforward. So x squared divided by x will remain just x, then minus square root of x is the same thing as having x raised per half, then this is like divided by x to the power of 1. So this is same as having this. So if you remember our law of indices, when you have division, it's the same thing as subtracting the power. So it's like saying minus x to the power of half minus 1. So that will be x minus x to the power of, this becomes minus half. So now I can integrate this function now, which is x minus x to the power of minus half with respect to x. So when I integrate x, normally I know it's just going to be what? X squared divided by 2. When I to integrate this, what do? I have x raised power minus half, then I add 1 to the power plus 1 over then minus half plus 1 based on our formula for integrating multiples of x. So I now have plus my constant of integration. So what does this become? I have x squared over 2 minus x to the power of minus half plus 1 gives me just half, then over half plus c. So if I bring this half over, 2 comes up. So this becomes the same as saying x squared over 2 then minus 2x raised per half plus c. And if you remember from our law of indices, x raised per half is the same thing as having the square root of x. So finally this becomes x squared over 2 minus 2 root x plus c. So that is the answer, x squared over 2 minus 2 root x plus c. So what option corresponds to that? And I'll say that what? That is option A. So the correct option to this question is option A. Now you should notice something, that you have plus k. So in theirs, they represented the constant of integration by the letter k while we use t. So it does not really matter what you use to represent your constant of integration. What matters is that you include it. So let's move on to the next example. And here we are told to integrate 1 over x plus cos x with respect to x. So what does that become? So that is something like finding the integral of 1 over x plus cos x all with respect to x. So this is something as having the integral of x to the power of minus 1 plus cos x dx. And if you remember, when you are integrating algebraic or sums, what do? You just integrate each term individually. So this is like having the integral of x to the power of minus 1 dx plus the integral of cos x dx. Now what is the integral of x to the power of minus 1? If we try to use our normal formula for integration, if you remember, we said x to the power of n is equals to, when you try to integrate x to the power of n, is equals to x to the power of n plus 1 over n plus 1 if n is not equals to minus 1. But we told you that it is equals to ln if n is equals to minus 1. So as you can see, as n here in this case, x to the power of n, as n in this case is equals to minus 1, we cannot apply this formula, because if we apply our general formula, what do we get? We get x to the power of minus 1 plus 1 over minus 1 plus 1. So we get x raised per 0 over 0, which is 1 over 0. And what is 1 over 0? It is undefined. So because it is undefined, because we have 0 as the denominator. So to avoid a situation like this, that is why we just say when n is equals to minus 1, the integral will just give you ln of x. So the integral of x to the power of minus 1 over 1 over x is what? Ln of x. And while the integral of cos x, as we've talked about before, is what? Sin x. So this becomes ln x plus sin x. And as usual, don't forget to add your constant of integration. So the integral of that function is what? Ln x, which is the integral of 1 over x, plus sin x, which is the integral of cos x, then plus our constant of integration. And what option corresponds to this? That is option B. So the correct option is what? Option B. So on to the next example. We are told to integrate cos 4x dx. So I'm going to solve this using the long way and the short way. So let's start with the long way. So now as you can see, we have 4x here, so we cannot just integrate directly. So we have to replace this 4x. So we say let u be equals to 4x. So what is my du over dx? My du over dx becomes what? The differentiation of 4x gives me 4. So if I make dx display the formula, so my dx becomes du over 4. If I substitute the value of 4x as u and dx as du over 4, this becomes what? The integral of cos u. Then my dx becomes what? Du over 4. So now this is the same thing as having the integral of cos u, then I bring out my 4 du. Now when I integrate cos u, what do I get? I get sin u. So this is like having 1 over 4 times sin u, then plus my constant of integration. And the value of my u is 4x. So which is the same as having 1 over 4 sin 4x plus my constant of integration. So that is the answer. How about if you don't want to go about it using this long way? So you can solve this directly in your mind. And how do you go about that? So the integral of cos 4x dx. So we first assume that this is a single variable, like this is a single x. So when you integrate cos this, it gives you sin 4x. So you have sin 4x. But in reality, this is not also a single value. So you now divide it by the differential of 4x. And what is the differential of 4x? You get 4. So you have sin 4x over 4, then plus my constant of integration, which is the same thing as we got here. Just that I've skipped many steps and just solved it directly in my mind. So what option corresponds to this? You can see that the option that corresponds to this is option D. So the correct option to this question is option D. So now we are told that if dy over dx is equal to 2x minus 3 and y is equal to 0 when x is equal to 0, find y in terms of x. So in other words, we should find the function. So if I cross multiply, I'm giving the gradient function. As you can see, dy over dx is equals to 2x minus 3. And if you recall, to get the original function from the gradient function, what we have to do is to integrate the gradient function. So now how do we do that? We first cross multiply. So we have dy is equals to 2x minus 3 dx. So if we integrate both sides, I have now my y is equal to the integral of 2x minus 3 times dx. So now I can integrate this easily. So y is equal to, when I integrate 2x, I get 2x squared over 2. And when I integrate minus 3, I get minus 3x, then plus my constant of integration. So if I simplify further, what does this give me? I have y is equals to x squared minus 3x plus my constant of integration. But I can find my constant of integration because I'm told that when y is 3, x is 4. So I'm told that when y is equals to 3, that the value of x is equals to 0 rather. So if I substitute it here, I get 3 is equals to 0 square minus 3 into bracket 0, then plus c. So that means my c value is equals to 3. So when I substitute it back to my original function, I get my y to be equals to what? X squared minus 3x plus 3. So expressing y in terms of x, so y is equals to what? X squared minus 3x plus 3. And that makes D the correct option. So let's move on to the next question. And as you can see, this question has to do with definite integrals because I'm giving boundary conditions. So I'm told to integrate x cubed plus x squared from 2 to 0. So now if I integrate this function, if I integrate x cubed, what do I get? I get x raised power 3 plus 1, 4, then over 3 plus 1, which is 4. Then this becomes plus x raised power 3 over 3, because when I add 1 to this power, I get 3, then over 2 plus 1, which gives me 3. And as you recall from our discussion on definite integrals, you did not need to include the constant of integration, because eventually they are going to cancel out. So I'm integrating from 2 to 0. So I first substitute my upper limit. So you remember, to simplify this, I also have my what? My upper limit, then minus my lower limit. So my upper limit is where my value of x is 2. So I substitute everything here with 2. And what does that give me? So I have 2 raised power 4 over 4 plus 2 raised power 3 over 3, then minus my lower limit. For my lower limit, the x value is 0. So I replace x with 0 over here. So I have 0 raised power 4 over 0 plus 0 raised power 3 over 4 plus 0 raised power 3 over 3. So what does that become? 2 raised power 4 is 16. 16 divided by 4 is 4. So I have 4 plus 2 raised power 3 is just 8. So I have 8 over 3. And this becomes 0 over 4 is 0, and 0 over 3 is 0, minus 0. So this becomes 4 plus 8 over 3 is 2 number 2 over 3. So when I add it together, it becomes 6 number 2 over 3. And what option corresponds to that? Option B. So the correct option is option B. So on to the next question. Here is also related to definite integrals. I was told to find the integral of cos x dx from pi over 2 to minus pi over 2. So the same logic applies. So when I integrate cos x, what do I get? From our standard integrals, I get what? Sin x. So I'm integrating sin x, and my boundary conditions are pi over 2 to minus pi over 2. So I have to substitute the value of pi over 2 first. So this is same thing as having my upper limit in this case will be what? Sin pi over 2, then minus, open bracket, I substitute my lower limit, and x value will be minus pi over 2, sin minus pi over 2. So how do we replace this or simplify this? If you remember our discussion from trigonometric ratios, when you have pi in terms of angle, we know that pi of radian is equals to what? 180 degrees. So pi over 2 will just be what? 180 over 2, which is the same thing as having 90 degrees. So pi over 2 is the same thing as 90 degrees. So I can substitute this as having sin 90 degrees minus sine of minus 90 degrees. Now if you punch your calculator for sin 90, you get 1. And if you punch your calculator for sine of minus 90, you get minus 1. So this becomes minus times minus is plus 1, and that gives me 2. So the correct option is option C, which is 2. So in this next question, it's quite similar to what we solved before, but now we're told to integrate sin x minus cos x from pi over 4 to 0. So what does this become? So when I integrate sin x, what do I get? I get minus cos x, then minus, when I integrate cos x, I just get sin x. So I have minus sin x, and I'm integrating from pi over 4 to 0. So I first substitute my upper limit. So remember, you have your upper limit minus your lower limit. So when you substitute the value of the upper limit, which is pi over 4 for x, you get what? Minus cos pi over 4, then minus sin pi over 4, then minus my lower limit. I replace the value of x as 0. So I have minus cos 0, then minus sin 0. Then what we have to do now is just start to simplify. So as I've explained in the previous example, pi radians, when I'm talking about angles, is the same thing as having 180 degrees. So pi over 4 is the same thing as what? 45 degrees. So we know that cos 45 degrees is the same thing as sin 45 degrees, which is equals to root 2 over 2. So cos pi over 4 is root 2 over 2. So this becomes minus root 2 over 2. Sin pi over 4, sin 45 same thing as what? Root 2 over 2 also. Then minus cos 0 is 1. So I have minus 1. And sin 0 is 0. Minus 0. So when I collect the LCM over here, I have 2. So this becomes minus root 2. Then this becomes minus root 2. Then I have what? Minus times minus give me plus. Then I have what? Plus 1. So this becomes what? Minus 2 root 2 over 2 plus 1. So 2 cancels 2. And that becomes minus root 2 plus 1. Or you can write it as what? 1 minus root 2. So the integral of this from 0 to pi over 4 is 1 minus root 2. And as you can see from the options, no option here corresponds to that. So definitely, maybe the question is, the options are wrong. So you should note that the answer to this question is what? 1 minus root 2. So let's move on to the next question. Here we are told that the gradient of a curve is 2x plus 7 and the curve passes through point 2, 0. Find the equation of the curve. So this is also an application of differentiation, and to go about this, we are given the gradient. So given that the y over the x is equals to 2x plus 7. So we can find the equation of the curve by integrating the gradient function. So if we cross multiply, we know that the y will be equals to 2x plus 7 times the x. So if I integrate both sides, I have my y to be equals to, when I integrate 2x, I have 2x squared over 2. And when I integrate 7, I have 7x, then plus my constant of integration. So 2 cancel 2. I'm left with y is equals to x squared plus 7x plus my constant. But now I'm told that the curve passes through point 2, 0. So I know that when x value is 2, my y value is 0. So I can substitute that here to find the value of c. So when my y value is 0, so I have y as 0 is equals to my x value is 2. 2 squared plus 7 times 2, then plus c. So I have 0 is equals to 4 plus 14 plus c. So 0 is equals to 18 plus c. So c is equals to minus 18. So I can substitute it back into the equation. So I have what? Y is equals to x squared plus 7x minus 18. So this is the equation of the curve. And what option corresponds to that? That will be option B. So option B is the right option. So now here is the last question we are going to be solving. We are told to find the area bounded by curve y is equals to 4 minus x squared, and the curve y and the line y is equals to 2x plus 1. So to solve this, remember the formula we need to apply. So the formula says that we need to find the integral from a to b of my top function minus the bottom function, then dx. So where a and b are the point of intersection of these two curves. So I need to find the point of intersection, and to find the point of intersection, I equate these equations together. So my y of my curve must be equal to my y of my line. So when I equate both of them together, I have what? 4 minus x squared is equals to 2x plus 1. So if I bring this over here, I have 0 is equals to x squared plus 2x. Then this becomes plus 1 minus 4. So I have what? X squared plus 2x minus 3 is equals to 0. So I can try to factorize this. When I factorize, I have minus 3x. So when I multiply the first and last term, and what two terms will I add together to get this? I have minus x and plus 3x. So if I represent plus 2x with this, I will see quickly that I have what? X squared minus x plus 3x minus 3 is equals to 0. So x is common here, and I have what? X minus 1, and plus 3 is common to have x minus 1 is equals to 0. So the values of my x here ranges from, so my x now, so either have x plus 3 is equals to 0 or x minus 1 is equals to 0. So x value range from minus 3 or x is equals to 1. So the lower value represents my a, so my a is equals to minus 3 and my b value is equals to the second point of intersection, which is 1. So now that I found the values of a and b, I can find the area. So I know that the area is equals to the integral, the value of my a is minus 3 and my b value is 1. Then my top function is what? 4 minus x squared, then minus the bottom function, which is 2x plus 1, all with respect to x. So what does that give me? So I have my area to be equals to, so when I expand this, I get 4 minus x squared minus 2x minus 1 dx. And what does that result in? I have 1 and minus 3. So if I collect like times, this becomes minus x squared minus 2x plus 3 dx. So now I can easily integrate this, and when I integrate that, what do I get? Minus x squared becomes minus x cubed over 3, minus 2x becomes minus 2x squared over 2, same thing as having minus x squared, and 3 becomes plus 3x, and I'm integrating from 1 to minus 3 to 1 rather. So now our area will just be equal to what? The upper limit minus the lower limit. So for the upper limit, I just replace 1 with the values of x here. That becomes minus 1 raised power 3 over 3 minus 1 squared plus 3 into bracket 1. Then minus the lower limit, I just replace x as minus 3. So I have minus into bracket minus 3 cube over 3, then minus 3 squared plus 3 into bracket minus 3. So what does that give me? 1 cubed, so this becomes minus 1 over 3 minus 1 plus 3, and this becomes minus 3 cubed is minus 27. Minus 27 times minus give me plus 27. 27 divided by 3 gives me 9. Minus 3 squared is 9. 9 times minus gives me minus 9. And 3 times minus 3 gives me what? Minus 9 also. So minus 1 over 3 minus 1 plus 3 gives me 5 over 3. Then minus, then 9 minus 9 minus 9 gives me minus 9. So it's the same as having what? 5 over 3 plus 9. Now 5 over 3 is same as having one whole number, 2 over 3 then plus 9, which is same as having 10 whole number, 2 over 3 squared units. So the correct option to this question is option B. So to recap again, what we did was we first found the point of intersection between the curve and the line by equating the equations together to find the values of x. So the lower value was assigned the value of a and the upper value, greater value b. So we integrated between those 2 points of intersection. So we subtracted both functions from each other before integrating from minus 3 to 1, and after we accomplished that, we got our area to be equal to 10 over 2 over 3 squared units. So this pretty much sums up the kind of questions that you have to expect in your JAMB exam. So one way, or the only way through which you can perfect your skills, is to try to solve more questions. So I will encourage you to try to go through the exercises now and try to see if you can attempt the following questions. And when you are done with that, you should also try to go through your past questions so that you can solve more questions, because practice makes perfect. So that will round up our discussion on integration. Bye for now.